In this presentation, I'll be discussing how you can distinguish between cis-trans isomers. So mainly physical as well as chemical methods for distinguishing will be discussed in brief. First of all, we have to know what is the difference between cis and trans isomer. Cis isomer, as we all know, will be having similar groups or atoms on the same side, whereas in the trans, the similar atoms or group will be aligned opposite to the double bond. In most of the cases, cis will be more polar and trans will be less polar or non-polar. And the cis will be loosely packed, and hence the melting point of cis isomer will be comparatively lower. But in the case of trans, they will be highly packed and they will be having higher melting points. However, when we are coming to the force of attraction and boiling point, since cis isomer is a polar, in the most of the cases they will be having higher boiling point and stronger attractive forces. So this strong attractive forces itself is the reason for higher boiling point. But in the case of trans, the boiling point will be comparatively lower than the cis isomer since there is no strong attraction. And cis isomer will be highly soluble in inert solvents, and trans will be less soluble in inert solvents, and they will be having higher acidic strength in the case of cis isomer, and trans will be having lower acidic strength. And we have a particular rule which says among cis and trans isomer, the cis will be having higher density and refractive index and lower molecular refractivity than the trans. This particular law is our Skeeter rule. So this particular rule states that these physical properties, that is density and refractive index, will be higher for cis, whereas molecular refractivity will be lower for cis. There are various methods for determination of the geometrical isomerism shown by a compound, whether it is a cis molecule or a trans molecule. There are various methods. Of these, important one are NMR, vibrational spectra or Raman spectra, and refractive index measurement, density measurement, boiling point measurement, dipole moment measurement, etc. UV visible spectra can also be used for determination of the cis or trans isomers, but it is not much reliable. And also mass spectra, X-ray electron diffraction method, as well as microwave spectra can be used in rare cases. So of the various methods, the simplest methods are those methods which base on the physical properties, that is refractive index, density, boiling point, dipole moment, etc. All these methods have been already discussed in the previous slide, that is refractive index, how that would be different for different materials, density, how that would be different for cis and trans, boiling point. When you are considering cis and trans, cis will be having higher boiling point than trans, and dipole moment. Obviously cis would be more polar and they will be having dipole moment, a particular value dipole moment. In the case of trans, they will be having lower or zero dipole moment. All these things we have discussed when we discussed about the difference between cis and trans isomers. So here you can see how these physical properties would be varying. When you are considering dipole moment, cis will be having higher dipole moment, trans will be having zero or very low dipole moment. So here you have 1,2-dichloroethylene. The cis 1,2-dichloroethylene will be 1.89 dipole moment. However, in the trans isomer, the dipole moment would be 0. Similarly, for cis 1,2-dibromoethylene, the dipole moment would be 1.35, whereas trans would be having 0 dipole moment. When you are considering polarity, cis will be polar, whereas trans would be less polar or non-polar. And when you are coming to boiling point, in most of the cases, cis will be having higher boiling point and trans will be having lower boiling point. and melting point will be lower for cis because of loose packing, whereas for trans it will be higher. If you are considering the malic acid and fumaric acid, you can see the melting point of malic acid will be 130 degrees Celsius, whereas fumaric acid will be having 300 degrees Celsius as the melting point. So these are the simplest physical properties that can be measured, or physical constant that can be measured in order to determine whether the given compound is cis or trans. NMR spectra can be used for determining the geometry of particular molecule. So usually trans isomer would be more downfield and the cis isomer would be more upfield. And using the coupling constant, you can say whether that is cis or trans. The vicinal coupling, if the J value is between 6 and 14 Hertz, can say that is cis. And for trans, the J value would be much more higher, the coupling constant would be higher, that is in between 11 to 18 Hertz. So here you can see in this particular case the coupling constant is about 9 Hertz, and here in the trans isomer or E isomer you can see 14 Hertz as the coupling constant. In this particular case, the phenyl groups are in the cis position, they have a coupling constant of 6.49 value Hertz, and here in the trans isomer the value is about 6.99. And vibrational or Raman spectra, IR or Raman spectra, can be used for saying whether the molecule is having a cis geometry or trans geometry. In the case of trans molecule, there won't be the CC stretching or carbon-carbon symmetrical stretching would be having zero dipole moment change, so it won't be observed in the case of IR spectra, but it will be observed in the Raman spectra. This, in the case of cis isomer, both IR and Raman spectra can be used to see the CC stretching. So CC stretching would C double bond C stretching would be present in the case of cis 1,2-dichloroethane in IR and Raman spectra, but in the case of trans isomer, the C double bond C stretch would be absent in the IR spectra and present in the Raman spectra. This is due to the difference in dipole moment. And coming to the chemical methods can be used for distinguishing between cis and trans isomer. The best example is malic acid and fumaric acid. Malic acid is a cis isomer and fumaric acid is a trans isomer. Upon heating, malic acid easily will be converted to corresponding malic anhydride at a lower temperature. But if you are applying the same temperature on fumaric acid, it won't be undergoing easy cyclization to form the corresponding anhydride. Fumaric anhydride would not be formed. Instead, it will be undergoing isomeric change in isomerism or change in the conformation, geometrical isomerism. It will be converted to the corresponding cis isomer. Upon heating, it will undergo isomerization to give malic acid, which will further undergo the cyclization or formation of malic anhydride. So there are physical as well as chemical methods that can be used for determining the geometrical isomerism, and boiling point, melting point, dipole moment, polarity, etc. are the simplest methods that can be used for determining whether the given compound is cis or trans. And using NMR spectra, IR spectra, etc. also we can determine whether the bond is cis or trans. And by chemical methods, by heating and all, you can say which compound is cis and which is trans. This is all. Thank you.